So let's so can you able to see my screen, Sandeep? Yes. Yes. Okay. So good evening once again. Let's continue with the biomolecules for today. So yesterday we were discussing about the monosaccharide part, right? So glucose we have discussed yesterday, and today we are going to discuss about the fructose. Got it? So fructose is again a monosaccharide and of molecular formula C6H12 and O6. So the major source of fructose is nature again, like glucose. Like in fruits and vegetables, you can find this fructose, and in honey also you can see. Got it? And coming to the preparation of fructose is same as that of glucose. So in under glucose, we have studied two preparation, and the first one will fall under this category. From sucrose on hydrolysis in presence of HCl or H2SO4, you'll get glucose and fructose. So the same reaction we have seen under the preparation of glucose also. Okay. So in its pure form, fructose is used as a sweetener. Got it? It is a natural sweetener. Got it? So next, moving on to the structure of fructose. Again, we have two different structure like glucose. One is open chain and the other one is cyclic chain structure. Now coming to the open chain structure. So Sandeep, am I going very fast? You can able to follow, right? Preparation part and all we have discussed yesterday only. So that's why yeah, yes. Okay, I'll go for the open chain structure of fructose. Okay. So the formula is again given to you. On the basis of chemical reactions, the structure of fructose contains 6 carbons in a straight chain. Okay. So you can see here all the 6 carbon atoms are arranged in a straight chain, and it contains a ketonic functional group at carbon number 12, carbon number 2. In case of glucose, we had the aldehyde group in carbon 1, and here we have ketone in carbon number 2. Okay. And it belongs to D series. It is free. It rotates a plane polarized light in the anti-clockwise direction, that is towards the left. What are these? Are the structural information of fructose. So just note it down or take a screenshot. Yes, Akhil, good evening. Good evening. So students, have you noted down the points which are here in the slide? Shall I move on to the next slide? Shall I? Yes, thank you, thank you. So coming to the cyclic chain structure of fructose, so here is the open chain structure. So in the same way we have prepared for glucose, we are going to prepare the cyclic structure for fructose also. Okay. So the last before carbon, that is the fifth carbon, which is having the OH, will go and attack the carbonyl carbon. Got it? And we get a structure, we get a cyclic structure. So the lone pair of electrons which is present on this oxygen, it will go and substitute, attack this carbonyl carbon, and the electrons which are pi electrons which are located here will shifted to oxygen, and that minus, that negative charge will come and take this hydrogen. So what we get basically, we get OH attached to the second carbon. Okay. So we get an alpha D minus fructose, and also if the attack is from the other side, if the attack is from the left side, we get one more system. Okay. We get one more compound, that is OH is attached to the carbon in the left side. So two different compounds are formed. One is alpha form, the other one is beta form, like glucose. Now, how many membered ring it is? Can you find out how many membered ring it is? Glucose is a 6-membered ring, right? So fructose is a 5-membered ring. You can see. So this is number 1 and this is 2, 3, 4 and 5. So we get a 5-membered cyclic structure for fructose. So it forms 5-membered cyclic compound with 1 oxygen and 4 carbon atoms in the ring. Got it? So this is the 5-membered structure you can see. So carbon number 1 is attached to carbon number 2. It will not, carbon number 1 will not involve in the ring. Okay. And I know I told you how to draw the structure, right, yesterday. So the components which are present at the right side of this Fisher projection will occupy the bottom part. Okay, suppose in case of second carbon, you see OH is at the right. So they'll come down. So the components which are in the left side will go up. Got it? And in fourth carbon, we are having OH at the bottom and fifth carbon. So for last before carbon, there is an exception I told you yesterday itself. For this alone, what you have to do? You have to place the atom which is left in the bottom part. That is hydrogen should come in the bottom part. And the CH2OH is carbon number 6. Got it? So this is the alpha D fructofuranose. Got it? And the other one is beta D fructofuranose. So what is the difference between alpha and beta? So here the OH will be in the bottom position and in the beta form the OH will be in the top position. So the same difference. Got it? And why do we call this structure as fructofuranose? Any idea? Why are we calling this as fructofuranose? Why do we call this as fructofuranose? Since it resembles the furan ring. So this is the furan ring, tetrahydrofuran ring. So since it resembles the furan ring, we are calling it as fructofuranose. Got it? So that's all about the monosaccharide part. So yesterday we have discussed. So biomolecules were classified into 4. We have discussed yesterday, and under carbohydrates we had 3 different categories: mono, oligo, and poly. And under mono, glucose were discussed yesterday, and fructose I have discussed today, the open chain structure and closed chain structure. Got it? Now next we are going to see the oligosaccharides and polysaccharides, which is the part 2 of this carbohydrates. Shall I go with that? Do you have any doubt here till the monosaccharides, both of you? Yes. So let's go for the second part of carbohydrates, which are about the di and polysaccharides. So disaccharides and polysaccharides will be discussed here in the upcoming slides. So the first is disaccharide. Okay. So what are disaccharides? The compounds which on hydrolysis with the dilute acid or enzyme, if they form 2 different monosaccharides or 2 to 10 monosaccharides, they are called as oligosaccharides. Okay. If it is specifically forms 2 monosaccharide, then it is called as disaccharide. Got it? Oligo means 2 to 10 monosaccharide units will be getting, and in case of di, you get only 2. If you get 3 monosaccharide, it is called as trisaccharide. If you get 4, it is called as tetrasaccharide. So di means a compound on hydrolysis forms 2 monosaccharides. Got it? Those 2 can be same or those 2 can be different or etc. And disaccharide is of sucrose, maltose, and lactose. These 3 are the examples of disaccharides. Sucrose contains aldehydic or ketonic groups attached to it, and it is called as a non-reducing sugar. Okay, sucrose is the only non-reducing disaccharide. Maltose and lactose also contains aldehyde and ketone group, but those groups are free. You can do the reactions in the aldehyde and ketonic part of that particular structure. Okay. So if you can do the reaction on those particular center, then you can do tolerance and you can do Felling's test and all. No. So if the system is contain CHO group, that CHO will be oxidized to COOH. So what you will get? You will get oxidation reaction. So you can do the reaction. You can reduce or you can oxidize the thing. So they are called as reducing sugars. They are called as reducing sugar. So the very important question here is, they'll ask you, find out the only non-reducing disaccharide among the following. So the answer is sucrose. Sucrose is the only non-reducing sugar. Got it? You cannot reduce it. Carbonyl systems are bonded with the cyclic system. Got it? Any doubt you have here in this? Shall I go for the next? Yes. So coming to the structure of sucrose. Sucrose is the first disaccharide we have seen. So this is the structure of sucrose. You can see, and the other one is beta D fructose. So these two monosaccharides constitute to a molecule called sucrose. And OH, here we would have had OH, and here also we would have had OH in the fructose and glucose molecule. So what you have to do? You have to remove the H2O molecule and you have to attach this oxygen to this carbon. So this is that oxygen basically. This is that oxygen. Okay. So on removal of water from this glucose and fructose, we are arriving at the sucrose molecule. Okay. So this linkage is called as glycosidic linkage. This linkage is called as glycosidic linkage, which is formed between the carbon number 1, between the carbon number 1 of glucose and between the carbon number 2 of fructose. So it is formed between the C1 of glucose and C2 of fructose. Got it? So the oxide linkage formed between two monosaccharides by the loss of a water molecule is called as glycosidic linkage. So C1 of alpha D glucose forms this with C2 of beta D fructose. And it contains one glycosidic linkage between these two. The reducing groups of glucose and fructose are involved in glycosidic bond formation. So which is the reducing group? So in glucose, carbon number 1 is the aldehydic carbon, right? So that carbon's oxygen is involved here. So it is not available. It is not available for the reaction. So you cannot do any reaction here. So that's why this sucrose is a non-reducing sugar. Got it? In fructose also you see, in the second carbon only we had ketone, and that ketonic carbon is involved in the glycosidic linkage. It is not free. It is bonded. Aldehyde and ketone containing so carbons are bonded here. So only if it is free, you can do the reaction, and those are called as reducing sugar. Since they are bonded, you cannot do the reaction, so they are non-reducing sugar. Okay? Got it? Yes. Sucrose is a non-reducing sugar. So Sandeep, have you noted it down? Aldol? No, it is not aldol. Aldol means we do the reaction between two aldehydes or two ketones in presence of a base. But here we are not using any such base. Okay. And also we are not having any double bond over here, no? No. This is not cross aldol also. It is removal of water like aldol condensation, but the name of the reaction is not aldol. In aldol, we use a base. We use sodium hydroxide or barium hydroxide, potassium hydrate kind of base, and we remove the alpha hydrogen there. But here in this case, we are not removing any alpha hydrogen. We are just eliminating the water molecule. Okay? Got it? What we use here? We do not use anything here. Just the water molecule gets removed by the nucleophilic attack. Okay? Yes. Shall I move on to the next structure? Yes. Okay, let's see some properties of the sucrose before moving on to the next structure, which is maltose. So sucrose is rotating the plane polarized light towards clockwise direction. So it is dextro-rotatory in nature, which I was discussing with you yesterday. It is having the plus configuration. Okay. But sucrose on hydrolysis, they produce glucose and fructose. Na? So these two, glucose and fructose, they also have some optical rotation. Glucose is dextrorotatory, that is it rotates the plane polarized light in clockwise direction, and fructose is levorotatory. It rotates the plane polarized light in anti-clockwise direction, and they have the optical rotation of these values. Glucose is having optical rotation of 52.5 degree and fructose is having minus 92.4 degree. Since it is rotating towards anti-clockwise, we are representing it by a minus symbol. Okay, so you should not take it in the way you see in the max. It is not lesser value. Minus denotes the representation of anti-clockwise direction. Okay, so which is higher, 52.5 or 92.4? Which number is greater among these two? 92.4 is greater number. Okay, so that's why the product is called as product is called as levorotatory in nature. So one is greater than the other. The one which is greater, it is dominating the other one. It is dominating the other one. Means the fructose is dominating the glucose. So what is the configuration? What is the rotation of this fructose? It is anti-clockwise. Means it is levorotatory in nature. So sucrose is dextrorotatory, but the products are levorotatory in nature. So hydrolysis of the sucrose brings about the change in the sign of rotation from plus to minus. So that's why it is called as invert sugar. The product is named as invert sugar. So it is rotation is getting inverted, no, from plus to minus. So that's why it is called as invert sugar. Did you get the concept? So shall I move on to the next thing? Yes. Second is the structure of maltose, which is the second disaccharide. Okay. So maltose composed of alpha D glucose and alpha D glucose. Both the components are same here. Okay, two same monosaccharide we are taking, and on removal of water, we are getting this maltose. And again, glycosidic linkage is formed between C1 of the first molecule and C4 of the second molecule. Hi Devan, good evening. Yeah, why have you joined late today? Okay. Is there any issue? Power cut. Okay. No issues, no issues. Okay, fine. So the linkage is formed between C1 and C4 of both the molecule. In case of glucose, the linkage is between 1 and 2, right? So here is between 1 and 4. All these things are very important. You should have a note of it. Okay. So here also the molecule contains only one glycosidic linkage between C1 of first molecule and C4 of the second molecule. But maltose is a reducing sugar. Maltose is a reducing sugar. Just take a screenshot of it quickly. Any doubt here in the structure of maltose? Sandeep and Devan? No doubt. Okay, I'll move on to the structure of lactose. So lactose is formed between beta D galactose and beta D glucose. So here two different monosaccharides are used. One is galactose, the other one is glucose. And also you see the glycosidic linkage. It is formed between C1 of first molecule and the C4 of the second molecule. And you can see the link is in zigzag manner. It is in zigzag manner. I'll come to that point later. There are two different types of linkage. One is alpha linkage, the other one is beta linkage. So beta looks like this. So why beta linkage is formed here? Because the monosaccharides which we took here are beta molecules. That's why beta linkage is formed. So means here we would have had OH and here OH. So the removal of H2O like this leads to this type of beta linkage. Okay. And lactose is a reducing sugar again. Only sucrose is non-reducing in nature. Got it? Noted it? Shall I go with the next topic? So I have discussed about the three disaccharide, which are sucrose, maltose, and lactose. Got it? So disaccharides got over. Now we are moving on to polysaccharides. So polysaccharides on hydrolysis with acid or some enzymes, they yield more than 10 molecules of monosaccharide. They yield many molecules, which is more than 10 molecules of monosaccharide. Got it? So you can see this GIF. Just see. So two more monosaccharides on hydrolysis, they form a disaccharide, and then on hydrolysis with the other molecule, they form a trisaccharide, and this chain keeps on going. This chain keeps on going till a 10 monosaccharide system and more than 10, which are called as polysaccharide. Okay. So see there, with the elimination of water, they are forming a glycosidic linkages, and till 3 is shown here. So more number of monosaccharides will come in contact to give the poly. So these polysaccharides mainly act as a food storage or structural materials. They act as a food storage or structural materials. You can see this in starch, cellulose, and glycogen. These three are the examples of polysaccharides which we are going to discuss now, one by one. Okay. So coming to the starch. So guys, did you take the screenshot of this? Shall I go with the next slide? Yes. So I'll come to the starch part. So the main storage polysaccharide of plants is starch. Yes. Thank you, Devan. Thank you so much. And then the main storage polysaccharide of plants is starch. The most important dietary source for human beings is starch again. Okay. So who are the sources of starch? Who are the sources of starch? Just a second. All the cereals, roots, and the tubers, and all the vegetables consist of starch. Right? These are just the general introduction about the starch. Now coming to the structure of starch. So it is a polymer of alpha glucose. Starch is a polymer of alpha glucose. Okay. So you all know alpha glucose. So there are two components of starch. One is amylose, the other one is amylopectin. These two are the components of starch. So now we are going to see few informations about amylose as well as amylopectin. Okay. So amylose is an unbranched chain polymer, and it C1C4 glycosidic linkage is present between the amylose system. Amylose is water soluble component. You can dissolve it in water, and 15 to 20% of starch consists of amylose. Okay, these are the points under amylose. And coming to amylopectin, it is a branched chain polymer of alpha glucose, just the opposite of amylose. Okay, and the C4 C1 glycosidic linkage is there, and also C1 C6 linkage is present. Okay, so in the linear chain C1 C4 is there, and between two chains there is a branch, And in that branch, you can find the C1, C6 linkage. I'll show you the picture. You can understand from that. Okay. I'll show you the picture in the next slide. And coming to the third point, it is insoluble in water and it constitute about 80 to 85%, which is the major part is occupied by amylopectin in starch. Got it? So all these points are very important. So just take a note of it. All these are just the informations which you have to know. So I'll explain you the concepts in the next slide. Shall I go for the next slide? Shall I go with the next slide? Okay, okay. Okay, okay. I'll go with the next slide now. So 15 percentage of starch is occupied by amylose and the remaining parts they are occupied by amylopectin. Okay. Now coming to the structure of amylose. So structure of amylose is it is a unbranched polymer, right? So you can see alpha D glucose on elimination of water molecule, they form the amylose part and the structure is of in linear format. Okay. And so these are the glycosidic linkages which are formed between C1 and C4 of both the glucose molecule. Coming to the structure of amylopectin, you can see, so there are linear chains. So these are the linear chains. These are the linear chains. In the linear chain, 1 and 4, carbon 1 and 4, they are forming this glycosidic linkage. But there are branches also. You see, this is a branch. For this particular chain, this is a branch, right? So that branch is formed between carbon number 1 and carbon number 6. C1, C6 linkage forms the branch. C1, C4 forms the linear chain. So totally this amylopectin is called as the branched polymer. That is a nature. Why is amylopectin? What is insoluble? So it cannot get dissolved. That is a nature. Some compounds are dissolved in water, whereas some are insoluble in water, right? So likewise, since the structure is, due to the branching component only. Since it is branched, the size of the molecule is very big. So it cannot, a big molecule cannot go in contact with the water molecule so easily. Okay, they cannot form the bond. Only if it goes in, only if the molecule goes in, forms a bond with the water molecule, the molecule gets dissolved, right? Since it is a big sized molecule, it cannot form the bond with water, so it is insoluble in nature. Got it? Because water is very small. Water is very small. It has oxygen and hydrogen. So this is water, small molecule. If a big molecule comes in contact with it, it cannot, if a big molecule like this, if they come in contact with it, it cannot form the hydrogen bond with water. Okay. So the solubility decreases over there. Clear? Yes. So coming to the next part. So C4, let me just erase this. Yeah, these two are C1 and C4 shown here for you, which are alpha linkages. And the cellulose. Cellulose is the second polysaccharide. So cellulose, it is the most abundant organic substance in plant kingdom. Most abundant organic substance in plant kingdom. It is a predominant constituent of cell wall of all the plants. Alpha linkage definition. So this linkage is formed between the two alpha D glucoses, right? That's why it is called as alpha. So water is getting eliminated from both the molecules in which the OH is in the same direction. Both the OH are here in the downward direction, no? So water is getting eliminated from this and they are forming the bond. So just now I have explained you, na? So this is the carbon. If H is here and OH is here in the first molecule, and for the other molecule, if you find OH at the top and H at the bottom, the elimination of water molecule occurs like this, no? So here what you will have a beta linkage. You will have a beta linkage. So this is alpha and this one is beta. So the alpha molecules produces alpha linkages and beta molecules produces beta linkages. Got it, Sandeep? Yes. So it is a predominant constituent of cell wall of plant cells, and cellulose is a straight chain polymer of beta D glucose. It is a straight chain polymer of beta D glucose. Okay. It is a straight chain polymer of beta D glucose. So this is the structure of beta D glucose, where you can see OH everywhere, which is attached to the first carbon in the top position. Okay. So this is beta. So in beta molecules, OH will be at the top. No, all these are beta D glucose, and on hydrolysis between C1 and C4, they form cellulose of this type. So this structure is called as cellulose. So these are the glycosidic linkages. Okay, and these linkages are beta linkages. Why they are called as beta? They are produced from beta D glucose. They are produced from beta D glucose. So here for this molecule, OH is at the top, and for this molecule, OH is at the bottom. So if a link is formed like that, you will get a system like this. No, yeah, it is formed from beta. That's why it is having beta linkages. This is the polymer. Cellulose is a polymer of beta D glucose. Got it? Shall I move on to the next slide? Yes. So third is glycogen. Carbohydrates are stored in animal body as glycogen. You might have studied in your biology very well about this. So whenever our body needs glucose, so what does glycogen do? So glycogen, with the help of an enzyme, it gets converted to glucose. Okay, and it is used in the energy spending purpose. Got it? So in carbohydrates are stored in animal body as glycogen. Very important point. So what are the three polysaccharides we were discussed? Cellulose, starch, and glycogen. Okay. Yeah. So all these three you should study. They are very important. And the difference between amylose and amylopectin is very, very important. Okay. Next, I'll go for the yes and the glycogen, cellulose, and starch. So coming to the importance of carbohydrates, so basically there are three main uses, important part of our food, and it is used in medicinal purposes, and some other uses are also there. Coming to the important part of our food topic, so where we use sugar cane, right? We eat sugar cane. So sucrose is present there, which is a carbohydrate. And in corn, starch is present there in corn. Starch is a polysaccharide. And glucose is present in the grapes. Okay. So these are the importance of carbohydrates in our food, in our daily food. Okay. And coming to the medicinal uses, so honey is a very rich source of carbohydrate which is being used in medicinal purpose. Okay, since it has many medicinal properties. And some other uses are also there. Cell wall is made up of the cellulose, which is a carbohydrate, and cotton fiber is made up of cellulose. Cotton fiber is made up of cellulose. Cotton fiber is made up of cellulose. Okay. Yeah. Yeah. That's what. That's what. So what we have discussed after monosaccharides, we have discussed disaccharides, sucrose, maltose, lactose, and under polysaccharides, starch, cellulose, and glycogen were discussed, and some important uses of carbohydrates I have discussed with you. So, is there any doubt you have from the carbohydrates part? From the carbohydrates part, shall I move on to the proteins? The next part, next biomolecule. Okay. So the second biomolecule is protein, and under proteins, I'm going to discuss the amino acids and their classification, the peptide bond, and classification of protein. Okay. So coming to amino acids and their classification, let me just introduce the protein to you. So protein is as derived from the Greek word proteos. Okay. It means primary or of prime importance, which are the primary, which are of primary importance, which require for growth and maintenance of body. Okay. And the source of protein is cheese, pulses, peanut, milk, fish, and then meat. So all these you would have known already, right? All these are the sources of proteins, which you have to take it in the daily diet. Got it? And all proteins are made up of, or they are the polymers of amino acids. Which amino acid? Alpha amino acids. All proteins are made up of alpha amino acids. So what is the structure of amino acid? So an amino acid contains an amine group and a carboxylic acid group. So it is called as amino acid. So a carbon is there. The carbon is attached with 4 different groups, and among those 4, one part will be occupied by amine group and the other one will be occupied by carboxylic acid group. Okay, and the remaining and in the remaining two part, if one is hydrogen and the other one is also hydrogen, then this particular amino acid is called as glycine. Okay, so amine group is the basic group and carboxylic acid is the acidic group. So there are different types of amino acids we have. We have alpha amino acid, we have beta amino acid, we have gamma amino acid, etc. So what is called as alpha amino acid? The carbon which is adjacent to this carboxylic carbon is called as alpha carbon. And if amine group is attached to that alpha carbon, then this particular amino acid is called as alpha amino acid. Okay. If it is attached to the next carbon, then it is called as beta carbon, it is called as beta amino acid. Got it? And if it is attached with the next third carbon, that is gamma carbon, then it is called as gamma amino acid. Okay? But here proteins are made up of alpha amino acids in which the amine group is attached to the alpha carbon which is adjacent to COOH. Okay? Do you have any doubt here, both of you? Shall I go for the representation of amino acid? Sandeepan Devan? Yes. So here is the structure which I have told you, and the 3 are fixed. Among 4 positions, 3 groups are fixed. One is hydrogen, and the second one is COOH, third is NH2. The fourth part, the fourth position, the fourth hydrogen, if it is replaced by some other groups, it will form some new amino acids. Okay. So if the fourth group is occupied by the same hydrogen, I told you no, the name of that particular amino acid is called as glycine. Why it is called as glycine? It has come from the word glycose, which is called as sweet. And the first three letter we are using it for symbol, and first letter is the code. Okay. And if that hydrogen is replaced by this particular aromatic system, it is called as tyrosine. So it is called as tyrosine. Okay. Like this, we can have a different number of amino acids. Now we are going to classify those amino acids into two. First is on the basis of acidic and basic nature. Second is on the basis of source. Okay. So coming to the basis of acidic and basic nature, it is classified into three. First is acidic amino acid, second is basic amino acid, third is neutral amino acid. So what are acidic amino acids? If the number of COOH groups is more in number than NH2 group, it is called as acidic amino acid, which is very easy. And if the basic group, that is if NH2 group is greater in number than COOH group, then it is called as basic amino acid. Example is lysine. And if both are in equal number, if a compound contain equal number of NH2 and COOH, then it is called as neutral amino acid, and the example is alanine. Okay. Can you able to understand it from the examples given here? First classification on the basis of acidic and basic nature. Both of you students. Any doubts so far? Okay. So amino acids are classified into two. On the basis of acidic and basic nature. Second is on the basis of source. Okay. So the first classification is on the basis of acidic and basic nature. And according to this, it is again classified into three, which you are seeing on the screen. That is acidic, basic, and neutral. So what is meant by acidic amino acid? If an amino acid contains more number of COOH group compared with NH2 group, then those amino acids are called as acidic amino acids. So you can see here in aspartic acid is an amino acid in which two COOH groups are there and only one NH2 is there. So COOH group is more than NH2. Okay, so it is an acidic amino acid. And in case of lysine, we have two NH2 group, two basic group and only one COOH group. So NH2 is 2 and COOH is 1. So what is this? This is a basic amino acid. And here in alanine, only one NH2 group we are having and only one COOH group we are having. So both are equal in number. Means alanine is a neutral amino acid. Is that clear now? Clear? Any doubt? Yes. So what is the second classification? Second classification is on the basis of source. On the basis of source, we can classify this into two again. One is essential amino acid, the other one is non-essential amino acid. So what are essential amino acids? So it is essential for health and to be supplied through diet. Means the amino acids which cannot be synthesized by our body, which cannot be synthesized by our body is called as essential amino acids. Your body cannot synthesize, but it is essential for you. For that, what you will do, you have to take those through diet only. Okay, they are essential. And what are non-essential? Which can be synthesized by our body is called as non-essential amino acid. It is not needed. It is not needed because already your body synthesizes that. It is not necessary. Okay. Able to differentiate between essential and non-essential? The compounds or the amino acids which cannot be synthesized by body are called as essential amino acid, and which can be synthesized by our body is called as non-essential amino acids. Okay, I'll show you the list of essential and non-essential amino acids in the next slide. So this classification is clear to all of you, right? Hope this classification is clear. Clear, na? Yes. So this is a list of essential amino acids. You have 10 essential amino acids, and these, just a second, these 10 are the examples of non-essential amino acids. Just take a screenshot of it. I'll show you the essential amino acid slide. So from valine, leucine, isoleucine, arginine, and lysine, threonine, methionine, phenylalanine, tryptophan, and histidine. All these 10 are essential amino acids which cannot be synthesized by our body, and it can be supplied only through your food diets. Okay. And the non-essential amino acids are these 10 from glycine till proline, in which your body can synthesize these. Shall I go for the next slide? Yes. Some properties of amino acids. So we have few properties. The first property of amino acid is it is a colorless crystalline solid. So you can see the crystals, right? Crystalline solid, which are colorless, and they are dissolved in water and they behave like a salts. Amino acids behave like a salts. They also form zwitterion. Actually, this is the third point. This is the third point. They form, yes. So they form zwitterion. How do they form the zwitterion? Just see the structure. The lone pair which is present on nitrogen, it goes and attacks the hydrogen which is attached to carboxylic acid group. The acidic hydrogen it attacks. So the electrons are shifted towards the oxygen, and you get an ionic compound like this. Okay. Since both positive and negative charge is present on the same molecule, this molecule is called as zwitterion. If a compound contains both plus and minus charge, the given compound is called as zwitterion. Okay. And this ion is in equilibrium with the molecule. You should have a note of it. The zwitterionic part is very important. So zwitterion is in equilibrium with its compound, with the amino acid, and this zwitterion is amphoteric in nature. What is meant by amphoteric? A compound which can react with an acid as well as a base is called as amphoteric compound. So zwitterion is amphoteric in nature, and the zwitterion is neutral also. Zwitterion is neutral. Okay. So it is forming a salt. Amino acid behaves like a salt by having plus and minus charges like NaCl. NaCl is a salt, right? In which it has both positive and negative charges. So likewise, here also it behaves like a salt. Shall I go for the next property? Shall I go for the next property? Any doubt here in the zwitterionic form of amino acid? Yes. So coming to the next property, optical properties of amino acid. So we are going to find out whether a given amino acid is optically active or not. So to make you understand with that topic, I have took this particular amino acid. Okay. And this carbon is called as asymmetric carbon. What is called as asymmetric carbon? Asymmetric carbon is called as chiral carbon. Asymmetric carbons are chiral. So what are chiral carbon? A carbon which is attached to 4 different atoms or groups are called as chiral carbon. And all the chiral carbon containing compounds are optically active in nature. All the chiral carbon containing compounds are optically active in nature. Yes, good. So since this particular amino acid is attached with 4 different atoms or groups, you can see the 4 different part. One is CH3, other one is H, COH and NH2, right? So it is a chiral system which is optically active. So amino acid are optically active except glycine. So why except glycine? All other amino acids are optically active. So you can see the structure of glycine here, in which the two groups which are attached to the carbon are same. Both are hydrogen. So it is not chiral in nature, right? Since it is not chiral in nature, it is optically inactive. So except, yeah, two same substituents we are having. So that's why glycine is optically inactive. Glycine is optically inactive. The only optically inactive amino acid is glycine. Very important question. The only optically inactive amino acid is glycine. Okay. No asymmetric carbon is present. Got it? Now coming to the fifth property about the D and L configuration of amino acids. So all the amino acids in which the NH2 group is present at the right side to the last before carbon are called as D amino acid, and if the NH2 group is present at the left side in your compound, it is called as L amino acid. Okay, like alpha and beta we have discussed, no? Alpha beta form of glucose, the same thing. Here you have to see the NH2 group which is attached to the last before carbon. If it is on the right side, it is D amino. If it is on the left side, it is L amino. So the properties of amino acids which I have discussed so far is clear to you, to both of you, Devan and Sandeep. So proteins are made up of amino acids, and we have discussed few information about amino acids. And tomorrow I'll continue with the peptide bond and the proper some structural informations of proteins. Then we'll go for the next biomolecule. Okay, protein is little bit bigger. Then the third biomolecule will be enzymes, hormones, nucleic acids. Those are very small topic only that we can complete it easily. Okay, only carbohydrates and proteins is a little bit big. Okay, fine. So I hope there is no doubt for you guys. So I'll meet you in the next class. Okay. So try to join it as soon as early as possible. Okay. Try to join at 4 p.m. at sharp. Okay. Thank you. Thank you so much. Bye bye.